Well, in this video, I want us to derive the quadratic formula, to show you how to derive the quadratic formula. Now, this may be useful because in the process you make use of completing the square method. And that's a method that is critical in having to find uh, when you'll be dealing with curves. If you are able to express a quadratic in using completing the square, that will allow you to easily identify the center and the coordinates of some of the points. So the going through how to derive the quadratic formula is useful in itself as such, because it at the end of the day we see why we use the quadratic formula and how it is derived. But again, the other benefit for seeing how it is derived is because in deriving it, I'm going to make use of completing the square method, which is also very useful. So we say, let me just start here. The quadratic formula. The quadratic formula. So a quadratic expression normally is an expression that the highest power of the variable of interest that we have is 2. And then we also have in the same equation the same variable, but now the slope changing with a defined constant. So the constants are going to be 3. We have A, B, and C, where A mostly is the coefficient of the highest power, and B is the coefficient of the one with the power 1, and then C is where the power is 0. So it's written as ax squared plus bx plus c is equal to 0, where a, b, and c are constants. They are constants. Where a, b, and c are constants. So this being the quadratic equation, this is a quadratic equation. So from the quadratic equation, we seek to make x the subject. And by making x the subject, then if we are able to determine or specify a, b, and c, then we can solve any quadratic equation using that particular formula. So let's see, because it's a general formula for getting a quadratic. It applies to all quadratic equations that conforms to this kind of form. So we'll say first, to apply completing the square method, we first have to divide to ensure that we remain with a coefficient of 1 here. That we can only achieve if we divide each term by a, and that will give us x squared plus b over a, x plus c over a is equal to 0. Plus c over a is equal to 0. And this is like saying x squared plus b over a x is equal to minus c is equal to minus c over a is equal to minus c over a is equal to minus c over a. Then we'll need to add, going by the quadratic, going by the completing the square method, we then need to get half of this coefficient here. Half of this coefficient will be b over 2a. So we will add square of that here and add it. We add it this end and add it that end. Now, adding it this end and adding it that end is like we still balance the equation because what we have added here is what we added there. So there's still a balance maintained. And so the next part in that case will be us having us having to say that x squared plus b over a x plus b over 2a squared is equal to minus c over a plus b over 2a squared, like that, b over 2a squared. Now, the b over 2a here, this and this b over 2a and b over 2a here, they are basically half of this coefficient, half of this coefficient. So b over a times half should give us b over 2a, should give us b over 2a. So this part here, whenever we perform this kind of operation, whatever is left here is one that we can express as a square on its own. So if you look at this, we can write all this, all of this at the end only. We can write it as x plus b over 2a, b over 2a squared. So the whole of this collapses to that. If you were to open up this bracket, then you'll see how that collapses to that. So you need to follow that, how and actually that's the main reason why we use computing the square method. The moment we carry out that operation, we are expecting to end up with something that is a square on this other end. And so we say we equate that to this, this one here. So that will then give us is equal to b squared over 4a squared equals 2a. So over 4a squared minus c over a, minus c over a, minus c over a, minus c over a. So what we have up to there is, so that is x plus b over 2a squared is equals to b squared, like that. So our interest here is to get the value of, to actually get an expression for x. That expression for x will now allow us to be, to solve for quadratic expressions or equations that we get once we are able to specify a, b, and c. So in this case, I want to make this side here more so that it looks better. So the LCM is 4a squared, yeah? LCM is 4a squared. And if it is 4a, the LCM is 4a squared. So that means here I just have b squared minus, this comes here, 4a times this. So minus 4ac, because this divides this, it is 4a times this, so it's minus 4ac. So here I come and say x plus b over 2a squared is equal to b squared minus 4ac over 4a squared. So I want to take the square root both sides. If I take square root here and square root there, I'll be having x plus b over 2a is equal to root of b squared minus 4ac over 4a squared. And this is like saying x is equal to minus b over 2a, because now this crosses the other end, I take the other end. So it's going to be minus b over 2a. But this being that this is a square root, the effect of having a square root is that you are either going to have positive or negative if that's squared. So I'm going to have plus or minus root b squared minus 4ac over 2a. It's over 2a because the square root of 4a squared is 2a. So that allows me to say, therefore, x should be given by minus b plus or minus b squared minus 4ac all over 2a. And that's the quadratic formula. Yeah, anywhere you meet the quadratic formula, you'll find it having this form. And that is how it is arrived at. By starting from a quadratic equation, we are able to apply completing the square method up to the point where we get the formula for getting values of x or any variable that is represented by the quadratic equation. So a will be the coefficient. They're just this as they are. Yeah. So once you are able to read what this coefficient is, what that is, plug it here, and you get the value of x. So that's that. Up to there. We meet in my next video.